Okay, so welcome to section 6.1, which is one-to-one and inverse functions. So one-to-one and inverse functions. Okay, so let's recall. So the graph of a relation, so the graph of a relation is a function if all vertical lines intersect the curve, in at most, in at most 1 point. At most 1 point. Known as the, of course, vertical line test. The vertical line test. Okay, so let's consider the graph of f of x equal to x squared. So x and y coordinate axes. Oof, boy. Okay, so x and y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. Okay, so the graph of x squared, 0 squared is 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, negative 2 quantity squared is 4, 3 squared would be 9, that's off the graph, negative 3 squared would be 9, that's also off the graph. So we get this nice U-shaped graph, something like so. Not drawn that great, but you get the idea. So this is my function, f of x is equal to x squared. So let's note, does it pass the vertical line test? It looks like every vertical line intersects in only 1 point. So let's note f of x is a function, hence the nomenclature f of x is a function because it passes a vertical line test. But on that note, no pun intended, let me actually move this line a bit over here for reasons. Oh, what in the heck? Which shall become evident. Do you know what? Okay, let's see. Okay, well, no, it's not letting me do it. Okay, never mind. Let me look at -1 and 1. If I plug those in. So what happens? Let's note. F of -1 would be quantity -1 squared. -1 times a -1 is a positive 1. Also, f of +1 is 1 squared, which is also 1. So there's two values of x's that map to the same value of y. So definition. Okay, so would be a good time to get out your symbols sheet. So a function f of x is 1 to 1. That's what we're defining, 1 to 1. Denoted 1 dash 1. If for all values of y in the range of f of x, so notice what I'm writing versus what I'm saying, there exists a unique, so that's a symbol on your symbol sheet, and backwards E with an exclamation point, that's there exists a unique, where was I? Value of x in the domain of f of x, such that backwards epsilon f of x is equal to y. Okay, so that is, i.e., it est, if I have that f of one value of x is the same as f of a different value of x, the only way that this is true is if they're the same. So notice above, I had two distinct values of x for the same value of y. That's not 1 to 1. So in other words, this is all to say, note, 1 to 1 functions pass the horizontal line test. So 1 to 1 functions pass the, quote, horizontal line test. Line test. That is, a function is 1 to 1 if and only if IFF every horizontal line intersects the graph, in at most 1 point. 1 point. Okay, so if we go back up to our parabola, clearly it does not pass the horizontal line test because there were two values of x which yielded the same value of y. So that's not a 1 to 1 function. Okay, so for example, so determine whether the following are 1 to 1. So determine whether the following are 1 to 1. Okay, so number 1. So x and y coordinate axes. Let me just do small x and y coordinate axes because I'm going to draw a lot of pictures here. I will copy and paste. Copy, paste. How many should I do? Looks like I have room for maybe 3. Okay, sounds good. Let's move them down 1, shall we? Move this down 1. Oops. This down 1. Okay, so what do we have? 1, 2, and 3. Okay, so first, let's say we have a picture or a graph that looks something like this, some sort of a cubic, like so. So is this function 1 to 1? Well, let's see. Let me actually do it in a... Well, notice this horizontal line intersects 3 times, so this is absolutely not 1 to 1. Okay, now let's see another cubic without so many sinuous guys. No, well, this one, notice every horizontal line will only intersect in one point. So this is one-to-one. Let's do the absolute value function. What does that look like? A v. So this f of x. And clearly, once again, I can draw a horizontal line that intersects in more than one point. So this is not one-to-one. Okay. But let's note, do you agree that if I took, say, just the positive values of x for that absolute value function, that on that portion of the domain, the function is one-to-one? So note. Note. So the domain of a function can be restricted. So the domain of a function can be restricted, so as to be one-to-one, for those values of x on which it is restricted. So for those values of x on which it is restricted.